We can see the screen all right, so that's good.
Put it on large screen and everyone should be able to see that. Nice and clear for everyone.
Perfect.
Right, excellent. Okay, so as it says on the front screen, we're a multi-award-winning now startup with a focus on changing the way we use energy, basically. We started actually in the middle of COVID. I'd previously been involved with another geothermal startup, which at the time I was living in Slovakia, taking them into a commercialization stage for their technology. And COVID struck, and one of the things that I immediately did was said to these guys, you need to go into survival mode. This thing's going to be around a while, and you need to keep the lights on, and you can't afford to keep me. So I sort of walked away from the business and moved back to the UK with my family, but with a sort of a mission in mind to sort of try and do something in the geothermal space. So we set CeraPhi up with a team of guys that were working with me in Slovakia, and I had the pleasure of working with. In that process of COVID, between the sort of start and sort of end of COVID, we focused most of the time setting up technology patents around novel innovations and technology itself in our application of what we were planning to do. Also, at the same time, it was a good time to pick up the phone and speak to people on Zoom and try and raise capital. So we raised quite a significant amount of money in that period of time, and also started then looking at grants and applications for technology development. So between sort of 2020 and 23, which last year, which was where we sort of had our first commercial sort of demonstration project, we sort of were in discussion with Third Energy up at Kirby Misperton. We sort of built a bit of a relationship with Russell and the team, with a focus on potentially looking at their assets to help them change the use of them from what was effectively a fossil fuel development into a clean energy sort of mission, really looking at using our technology to do that. And that sort of led us to doing our demonstrator there, which we did last year in 2003, which I'll come on a little bit more about information on in a little while. And also, now has helped us build a bit of a portfolio of projects now, which we have around £300 million worth of projects in development process as we speak. So the structure of the company is we're a UK limited company. We have a US office and also have two energy trading businesses, which is CeraPhi Energy. So these are our main what we call energy businesses. We are an energy company as we develop and grow, but we are an energy company that also develops and delivers our own projects with our own technology and innovation, which has also helped us raise capital and also helping us sort of raise capital for project development. And then we have our CeraPhi Drilling Solutions business, which is really the execution arm of our business to do the delivery work, which we need to install our systems and make them work. We're located primarily in the UK, is our head office, with a main office down in Great Yarmouth. Obviously, we do have some regional representation now in York, up in Pickering, Ryedale area. And we also have a head office in London, which is really corporate commercial office for financial and sort of investment type interface. We have an operational office in Houston in the US, which has people in it. And then we have representation through Brazil and the Middle East as a company. So really covering the South America and the sort of Middle East region, with a focus moving into probably Australia in the next 12 to 18 months as well. We have a large team. This is primarily the management team covering the business. We've built quite a strong team in the last three and a half years, including a number of advisors which come from quite credible backgrounds, or in very credible backgrounds in some cases, being sort of presidents and vice presidents of companies like BP. We have financial investment fund managers. We have the Royal Bank of Scotland manager. We also have a 3-star general from the UK Army, Sir Richard Nugent, who has really run the British Army for a considerable amount of time before he retired, and wrote the energy policy for the British, for the for the Ministry of Defence. So what's all this about? All this really is about is the best energy source we have in our disposal at our fingertips, really, which is the earth underneath which we walk every day. You know, the center of the earth is effectively the equivalent of the sun, effectively we're sitting on it and walking on it every day. But the temperature we have there is the same temperature as the sun, and we have access to it. It's radiating out all the time from the center of the earth. Historically, though, although we have used geothermal for many centuries and decades and centuries, going back right to Chinese and Roman times, and for heating and cooling and various other things, historically, it's not really been seen as the energy that can really help us moving forward, which is one of the reasons I really got into it and started to sort of push this forward. And a lot of that's to do with the perception as you can only do this when you've got volcanoes or volcanic activity around in places like Iceland and places where you have tectonic activity. We have the Ring of Fire going around the globe, which is very well known as a sort of earthquake zone, and the Pacific Rim is what they call it. And this is the place where most people associate geothermal with, because it's the most sort of active area where it's visible and you can see things coming through the surface through geysers or through natural sort of thermal springs, etc. But the actual energy itself is everywhere. So every kilometre of depth we go is about 30 degrees Celsius across the globe, and that's on a sort of equal playing field everywhere. So the deeper we go, effectively the hotter it gets. So we don't necessarily have to be on a side of a volcano or living in an earthquake zone to get access to this energy. There is around 27 countries now across the globe use geothermal for power generation, and over 70 countries around the world actually use thermal energy for direct use heat. But that said, there's less than 16 gigawatts of geothermal installed globally as we speak. There's probably around another 2 or 3 being built and developed, but actually only 17 commercial. And when you think about that, to put that into perspective, that's the size of an average wind farm nowadays being built offshore in the UK. So it's a very small amount of energy when you consider that it's probably one of the biggest baseload energies and cleanest energy we can probably ever get access to moving forward. So what we are looking at doing, and really is where our focus is really to try and tap into that energy anywhere and actually make it a ubiquitous all-around energy that can be used on a daily basis for everyone anywhere around the globe. A lot of the anomalies associated with this gives you a sort of either you have to find anomalies, and there are anomalies around where during over the Earth's crust you get hot and cold, cooler spots and hot spots around, and they can be, you know, quite shallow and they can be quite deep. But in theory, what a lot of the consensus is that drilling down to at least 4 kilometers and above is what you need to do to get access to deep geothermal, to create what they call a natural process to extract that heat and use it commercially. And that's what they call this a hot dry rock process, where, like in projects like United Downs in Cornwall and areas where you have hard rocks, granites, you drill down into them and then you effectively try and fracture the surface underneath and then flow fluids down one pipe and up another pipe, so you're circulating fluids around. That's called an enhanced geothermal system, effectively. So, and the reason it's called enhanced is because you're drilling down into a hot rock area, and then you have to effectively stimulate that area to make it connect before you can flow fluids around it to make it work successfully. And invariably, it doesn't work successfully, and there's lots of failed geothermal projects around the globe where people have pumped a lot of money into effectively drilling deep wells and not being able to connect them up because they haven't had the fractured subsurface to be able to do that. And this again comes into the emphasis or the word being used for fracking, for example, where they fracture the subsurface to connect wells together. So even in geothermal, in the conventional approach to geothermal, they do what is called hydraulic fracturing in a way to actually crack the subsurface to be able to get fluids to flow through them. So to come on to sort of where this can be used and why and how. So if you look at the map of the UK there, you'll see where we sit in Yorkshire. It's quite a nice little area. It's very hot, nice hot spots there, and you've got some good regions around that area for developing geothermal, along with the south coast. I mean, you're talking temperatures in the region of 40 degrees upwards, maybe to 45 degrees in some locations. But if you look at the average of the UK, it's still, in many cases, just above the average of 30 degrees, with the exception of some parts of Scotland and some parts of sort of Wales. But the majority of the UK is a good location for extracting heat to produce our heat networks and produce our developments for direct use heating and baseload energy. Which basically means that, we don't have to go and necessarily burn gas or burn oil or burn diesel or something like that to produce heat. We can use the heat from the ground. And invariably, that heat from the ground is very much the same principle as how ground source heat pumps work nowadays, but they're generally only drilled quite shallow, down to a few hundred meters, if that. But you'll see if you look at the maps on the left-hand side there, the Europe and the US, again, there's lots of hotspots around the US and Europe where it comes to geothermal energy, specifically around the sort of Central Europe area and sort of going down into Spain, over towards Turkey, these sorts of area. There's a huge amount of opportunity across the whole of Europe and in a lot of the parts of the US, specifically South Coast US down to Texas, and then over towards the sort of eastern side of the US, where a lot of the US geothermal projects are currently being developed, what they call around the geysers area of California, etc. There's a lot of different approaches to develop geothermal, and our approach is what we call a closed loop system. I mentioned the F word earlier, the fracking word, which a lot of people in our region in Yorkshire will know very well, is a word that has created a lot of turmoil over many years up there for various reasons. And one of the things that we eliminate by doing closed loop is that we don't have to frack, or we don't have to use the fracking process to stimulate energy recovery. And the reason being is because we're not using the subsurface in the same way as you would if you were drilling conventional wells and flowing systems through them wells. What we do is we drill a single monobore system, or it can be a multi-fingered type system, as you'll see on the right-hand side, which is a different company's approach. Our approach is very simple, and we've kept it simple because simple in drilling means lower cost and lower risk. The more complicated you get in drilling, the higher risk you create, and the higher potential of cost overrun and failure you can actually bring to a project. So we try to keep things very simple, drilling straight wells into the ground to a measured depth that we need to go to, and I'll come on to that in a minute. But generally, once we do that, we then completely case and line the well itself, so we don't have any connection with the subsurface at all. And then what we do is we circulate fluids through that system down to the bottom of the well, which conducts heat from the ground. And then we flow it, it goes back up to the surface with a working fluid, trapping that heat and bringing it to the surface for us to use for a commercial use, whether that be direct use heating or at higher temperatures, even power generation. So there are quite a lot of differences between what we call enhanced geothermal, which is a conventional geothermal approach, and what we call closed loop, which is what CeraPhi as a company have developed and specialize in as a company. I would also like just to add that in a closed loop scenario is we don't add anything into the subsurface, or we don't take anything out of the subsurface. So to get away from any myths of, you know, water table contamination, environmental impact contamination of things in the subsurface, that doesn't happen when you do a fully closed loop system, because you're actually working inside a confined closed system effectively, and the system is designed to ensure that, you know, the working pressures, temperatures, everything within that system are confined within the system and not able to get outside. So there is a huge impact of environmental benefits by going down the route of a closed loop system. So coming on to our technology a little bit now in how it works, very simply, it's like a tube in a tube process. So we would ideally drill a well, or in the case of what we did in Kirby Misperton in the KMA site, is we already had a well. So what we did there is we just plugged the hole in the bottom of the well and used the well itself as effectively the hole without having to drill the well from scratch. But let's look at the scenarios. If we were drilling a well, we would drill down to a measured depth that's required. That depth can be anything from 500 meters, maybe down to several kilometers in some cases. Our sweet spot of drilling or depth for heat networks is normally between 1,500 meters and 2,000 meters. I say sweet spot because that's given us our, what I say, working temperature that we require then to manage successfully what we call an ambient loop heat network system, which is suitable then for putting multiple connections into properties or homes or larger commercial buildings or infrastructure. The actual closed loop system we install is, in this case, we would use plastic pipe. So we are working with lighter materials, more advanced plastic, polypropylenes, these types of materials, which are getting better and better at thermal conduction and thermal insulation, meaning we get better properties and characteristics for the management of flow of materials and fluids around the system. And also, this pipe is a lot cheaper to make. It's a lot more environmentally friendly because, although it's plastic, it's actually lasts a long while and it's fully recyclable. So you can actually use it over and over again, as opposed to creating a carbon footprint or a larger carbon footprint with manufactured steel piping. And also, you don't have the need to treat plastic pipe the same as you do with steel pipe, with chemicals and corrosion inhibitors and things like this. So there's lots of benefit of using plastic pipe, which is one of the reasons we do this. We work with what we call a high, medium, low temperature threshold. I want to focus a bit more here on the medium and low temperatures rather than the high, because the high temperature is pretty unrealistic in most areas in the UK. So we are dealing with what we call a medium and lower temperature sort of rollout of technology here in the UK. But just to give you a sort of an insight, I've got slides in here to show you a higher temperature sort of application we are looking at in the process. But looking at medium and low temperatures, we can work with anything from sort of 30 degrees upwards in temperature wise. And that 30 degrees is more than adequate for working with a heat network, a smaller heat network system, specifically into a village or a small community. 30 degrees is more than sufficient to carry sufficient energy there to actually give people a very good quality energy from a base load perspective. So we are an energy company. We develop energy infrastructure, and we are pushing ourselves to become a utility business moving forward. We don't want to be a B2C business, a business selling energy to a customer. Ideally, we want to be a B2B business, which is like us building infrastructure, selling it to something like selling the energy to someone like a Octopus or an Ecotricity or something like that, and then they sell the energy, commercialize it to a third party customer, i.e. a domestic user, etc. We also have a very strong technology side in our software. So we, along with developing a solution in hardware to deliver energy, we also got a very robust software package which helps us model and design and actually optimize the energy production side, reducing cost and actually delivering the projects a lot more, should I say, technically advanced as we move forward. So we do a lot of data gathering in the office, a lot of information technology modeling to give us better idea and understanding of what's going on and how systems work. We're also one of the first companies to ever install fiber optic and modeling software in wells to actually model and see what's actually going on in the well while the well's producing and while it's operating. So not only do we actually look at what's going on the top side, we actually fully understand what's going on in the ground and what's happening with the energy, and we're able to learn from that significantly. So our business model, although we drill wells, as we've demonstrated in the situation with the assets in Kirby Misperton around Pickering, is that we are looking at repurposing infrastructure that was formerly designed for another use, primarily oil and gas wells, oil and gas infrastructure, but it can also be coal-fired power plants, gas-fired power plants, diesel generator stations, all sorts of infrastructure like that started out life as a fossil fuel driven piece of infrastructure, and we're now working with developers to change that infrastructure to be able to run on clean baseload geothermal, to then be able to connect their existing customers to a clean baseload energy other than just looking at decommissioning something and then changing the use of it. So we work across various different platforms in this way, and we're working with governments and organizations around the world in different areas, specifically emerging economies. But we have around 680 wells in the UK onshore, and it's a big part of our infrastructure to learn how we can use and how we can develop them assets and change them for a better energy source moving forward. So where we are in the acquisition of Third Energy, so we have purchased Third Energy. We did that later last year. We have in that process also relinquished the licenses for hydrocarbons. So this is quite a significant step. We're one of the first companies to actually take over onshore wells and actually give the hydrocarbon production licenses back to the government and say we don't want these anymore because we're not an energy company, even though we own effectively hydrocarbon wells. We're not producing hydrocarbons. We have no intention to produce hydrocarbons, and we don't need the licenses, so we're going to hand them back to you. In doing that, we still have an obligation to maintain the liability of them wells, but we are working with the regulators who recategorize them wells from being formerly hydrocarbon producing wells, in this case gas wells, to become effectively geothermal wells. So looking at the reuse of these assets going forward, so they are effectively going to change their position in life today from being a fossil fuel asset to being something else which has a more positive benefit moving forward from the long run. And that also then goes to drilling future wells or developing further infrastructure around these well sites to actually increase the energy footprint or increase the energy that can be done there. So a couple of examples of some of the projects we're looking at here is district heating. So we've been doing study work in different areas, in this case Little Borough and Great Hampton, looking at the villages and where we can potentially put clean energy from the existing well sites and wells that are there. And we have been awarded some local grants for doing these studies, and these are projects that hopefully in the next few months, certainly by the end of the year, we should have a lot more clearer picture on how we can go forward and develop these. And that includes Pickering and also Kirby Misperton. We're actually looking at projects there as well. This is a sort of combination of looking at heat networks into the village of Kirby Misperton, but also looking at potentially building commercial infrastructure on there. In this case, we're in discussion with a distillery manufacturer that wants to look at building some sort of distillery for the production of alcohol in the region. And we have a site, we have the energy, and we have the ability to do something there. So we've got quite a lot of approval, quite a lot of support. We are running local community engagement programs with the village and with other, we tend to do that going forward with other communities, and trying to really engage with the local community to do this moving forward, to actually make sure there's a benefit out of it for everyone. You know, being able to get the access to cheap, clean energy, you know, it's not easy when you're a village or in a small community, and the ability to do something and actually rectify a right or wrong of, say, a project that was started in had contention around the area, and actually be able to use that for a good cause moving forward has obviously got some value worth looking at. So our development solution is fairly simple. It's trying to reuse what we can, i.e. not all cases we will be able to reuse what we can, but where we can and where it makes sense, we'll reuse existing infrastructure and sites. But it also might mean drilling or adding additional wells and maybe additional infrastructure to them sites. So one of the things what we do when we develop and design a system like a heat network, you need energy to run pumps, you need energy to run other parts of the system. So rather than trying to plug that energy in and take that from a grid network, what we try and do is build the resilience around the site to be able to run the energy directly from a single source. That is normally something like battery storage and solar. So what we do there is we build in a small part of that. We're not talking about, you know, fields of solar or anything like that. We're talking about, you know, enough solar panels to cover the running of a pump or pumps on a site, which could be a few hundred kilowatts. But what it does mean is we're not then relying on the grid, and we actually make the project effectively an off-grid solution, meaning that the customer or end user has got complete clarity on the energy costs, and there's no fluctuation in utility costs over the lifetime of the project. And we can tie this in with obviously other commercial opportunities, which could be, as I said, distilleries, could be agricultural use, and there's also the wider picture of then linking up other communities into wider heat networks or heat systems moving forward. So when we look at that, this chart came from ARENA, which is one of the renewable energy institutes that comes out of Dubai, and this statistic came from 2021 actually, but it shows a good graphic of where we are in our energy mix. So when we talk about decarbonisation, and when we talk about, you know, we need to, you know, create a lot more energy for ourselves, the energy we're actually talking about has nothing really to do with power, because power only represents about 17–18% of our energy mix. We're actually talking the big chunk, or the big elephant in the room, is transportation and heat, with heating and cooling being the biggest chunk of that overall. And we still have a huge battle to go across the UK and most other countries, to be fair, to actually decarbonise ourselves. And we're not going to do it by, you know, despite what the government says, by filling our energy grid up with more air source heat pumps and things like this. We need to do it by a baseload energy which is at our disposal 24/7, and effectively doesn't create a different energy demand by installing it. So when we install things like air source heat pumps, we solve a heat problem, but we add an electric problem to the issue, because our grid then needs more electricity to run the heat pumps that we're installing. Whereas if we install heating and cooling systems from direct use heat, we actually alleviate the grid effectively on a 5:1 ratio. For every megawatt of heat we install through heating and cooling, we actually relieve the grid about 200 kilowatts of energy for the power demand. So it's a reverse way of actually helping the grid decarbonize from a power perspective by adding direct use heat and cooling. And some of the list of projects that we are currently looking at, you'll see there, and a lot of these are projects and things we are discussing in the areas of Pickering and you know, Malden and these sort of areas around the New York area, in York itself, looking at things like, you know, schools, sports facilities, swimming pools, local authority properties and buildings, etc. All these things are what we call key anchor loads, that if we can help decarbonize these directly, we then can help decarbonize local properties, residential properties and domestic users a lot easier, because you need a big anchor load to help commercialize this development, and the more bigger infrastructure we can install, the easier it is then for us to pass that down and help domestic users and residential users decarbonize as well. So one of the other areas we're looking at is, as I said, power generation. So we are doing power generation, although it's in the sort of maybe 5% of what we look at. This is a project we've been awarded in the Caribbean. So this is a project on an island in the Caribbean, which is a volcanic island, and at roughly about 2.6 kilometers, they have temperatures of around 230 to 250 degrees. So in them sort of temperatures, with the sort of depth we have wells there, we're able to generate power. And this actually works here as well, because the cost of power in islands is a lot higher than it is in generally, even though we're an island in the UK, you know, our cost of electricity compared with most islands around the world, or most emerging economies where you have an energy demand, or a growing energy demand, energy costs are exponentially bigger than what they are in the UK. For example, places in Africa where we're currently looking at projects have energy costs at the moment around $400 to $500 per megawatt, where we're paying 30 to 40 to 50 pounds per megawatt. So we're talking 10 times or more times the cost of energy in some of these countries. So it makes doing projects for power a lot more economical. It costs more to drill to deeper, it costs more to drill hotter wells, but the economics work out when you can sell energy for a higher premium in these countries and still produce baseload clean energy for them, and still produce, actually, even at $150 per megawatt, which this project is, this is still commercially very viable for them, probably half of what they're paying today for their energy generation. So to go and install these things, we also have to go and take our technology to the next generation, which is something that CeraPhi is focused a lot on. As I mentioned earlier, we're trying to drill between roughly 500 meters and 2 kilometers in new wells. And we are taking a different approach to do this. We're not bringing in big oil and gas drilling rigs to do this. We're using what we call geotechnic rigs, or sort of the geotechnic style rigs that are used for coring and boring holes around the UK on a regular basis, even in the water industry, boring and coring water holes. And what we're doing is we're adapting them, putting oil and gas sort of technology on them to be able to drill deeper and drill more cost effectively with these smaller rigs, in a space that's predominantly been dominated by oil and gas. And it's because it's been dominated by oil and gas that the cost of doing it has always been prohibitive. So what we're trying to do is drive that cost down by being creative and innovative with how we deliver these wells and how we move forward. And we're also doing this by adapting, as I mentioned earlier, the use of other materials like plastics, polymers and polypropylenes, pipes, etc., and increasing temperature working environments for these pipes, and also the design pressures for them, by working with manufacturers to do that. A lot of the manufacturers that we've approached to say, you know, can we push the working temperature of these pipes from 90 upwards, they immediately said yes. You know, why do you need it? And we explained it, and a lot of these manufacturers never been asked to produce pipes higher than that, because a lot of our working temperatures for our heat networks are around about the 80 to 100 degrees Celsius. But if we want to move forward into the next generation, we also got to look at power generation as well, and not just heat. So we want to take the temperature of these pipes up to 150 degrees. We want to increase the operating pressures of these pipes higher to increase integrity in the system, to avoid any spillages and you know, any design failures moving forward. But at the same time, then it allows us to step into a different world of power generation, as well as just looking at heat. And when I mentioned about the rigs, so this is one of the rigs we have recently just acquired. This is an Italian make rig. It's been designed to drill wells down to 2,000 meters using effectively oil and gas technology, but not oil and gas rigs. So we can drill deep wells using small rigs, This is about the same size as the rig we had on our Kirby Misbeaten site last year, which when we brought the rig through the village, nobody even knew we'd brought it in. When we set it up, nobody even really knew it was even working. So unlike historic events that have taken past and people complaining about drilling, these rigs are very small. They're very lightweight and they don't make a lot of noise at all. Not enough to actually warrant making any formal issues about. There is like every rig, there is a noise of operating, but very, very small and very low from a point of view of decibels. These rigs work on less than 70 decibels noise, which is well below the operating limits of machinery in public places. There are also electric rigs. You'll see the little one there in the middle, Comanche electric. This is the first electric rig now in the UK. So we are now also working with technology which is moving into a carbon zero footprint of even delivering the work. So we're actually getting to a point where we're actually getting technology rigs which can, specifically in built up cities and environments where we can plug a rig in and can use electric rigs. These types of things will be very, very welcome because of the noise is reduced even further. So some of the things that we're doing in the region and also globally is really looking at increasing innovation and technology in this space, which will in turn increase the labour and supply chain applications. So we're working a lot with suppliers and with colleges and institutions to train and develop people. So again, trying to bring existing skills but into a new generation of application, and hopefully that will create jobs and more innovation in the local community, but also in future development for keeping projects moving forward and keeping them developed, so we can actually build on a workforce using existing skills that we have across E&I, mechanical, electrical, instrumentation type skills, but also heating and cooling type people, ventilation and these types of areas, but bringing them into the next generation of innovation and technology. And this is really what we're doing. I mean, we've been tried to even on the local projects up in Kirby Misbeaten and working with the local areas last year. We tried to use as much local labour, local suppliers, increasing the local area where we could for helping the economy, and we continue to do that. Where we are is trying to drive that innovation and drive it locally. So I think this is my last slide. I did have a video, but I don't think we're going to play that. I think Paul will give you access to the video so you can get some homework and hopefully watch this offline and follow us if you have any further need to. And happy to hand over to Paul.
Fabulous. Thanks a lot, Karl. Good stuff and a big learning curve, I think, for a lot of us. Especially given kind of you're the leading edge of this. Do you want to stop the screen sharing, Karl? And I'll stop the recording. Wait, beat me to it. Let me just find the recording there. So surprise, surprise.